Okay, so next is we have another vec function. So it looks similar as the previous one, but now we have added t here. Just now we have z is just 5. So for any t, so the value of z is always fixed. So meaning that your curve in space is always lying on z equal to 5. But now because you have 5t, so your value of z is increasing by the increasing of t. Okay, so instead of you have only circle, you have in just like the helix shape. But now how can we obtain this? This one you are using a software or apps to provide you the graph. But then how can we manually sketch on by hand? So the procedure is the same as in previous example. When you have to use trigonometric identity, okay, so your f is 2 sine t, we have the same, and then minus cos t, and then 5t. Okay, so your x is 2 sine t, or parametric equation. Y is minus 2 cos t, and then your z is 5t. Okay, so in this case, x, y, and z always changing by the changes of the t. Okay, so for this, it's clearly seen that based on our previous example, this one always give you the circle with radius 2. Okay, meaning that when you plot on the 2D, which is on the xy plane, you always see the circle with radius 2 and the center at the origin. But when you plot that, this one when you convert into 3D, so it is no longer all the time you can see the circle, because this one, if you have this particular shape, this is you have a fixed z, but now you have a different z. So now how can we sketch that? So here you need some practices how to sketch the helix. So maybe I will start with just like before. Just provide t. So t equal to 0 equal to pi over 2 and then pi. So now we try to list down all the value of x and y. Okay, so when we choose a specific t, so these are the points that we have. You can see that the value of z is changing by the changing of t. As you can see that when you increase the t, of course the z is increasing. Okay, so now we want to plot all the 3 points on the 3D system. Okay, so why I put just like a cylinder? So this is not yet the helix that we want to sketch. So this one is just to guide you so that you have a correct shape. Okay, so meaning that based on the 3 points that you obtain here, so the first one we have at 0 minus 2. It's just like the previous example, we have this one. So this is the point, and since z equal to 0, so this is the first point. So meaning that you can sketch the position vector. So this is your position vector. So this is f when t equal to 0. Okay, and after that, the second, when t is pi over 2, so now you are at 2, 0. So 2, 0, x2, y0. So you have over here, but then your z is lying at 7.5. So imagine that the height here is 7.5. That is one is actually I already project this one from 2, 0 and then 207.9 here. Okay, why I put this one? Because as I mentioned before, if you are sitting up here, when you are looking down, you will always see this circle. All the time you can see the circle. You can see the circle from the above. When you're sitting down here and you are looking up, you can see the circle. But then if you are looking from here, it's not a circle anymore. It should be helix. Same goes here. You can see helix. But when you are sitting up here or down here, below here, you can see always the circle. So then that's why I put the circle here with the height is 7.9, which is projected from the point of 20 here. And then after that, the third point is located at x0, y2. So x0, y2 is actually from here. But then, because in 3D, we have the value of z is 5 pi, or we have about 16. So here, I'm assuming that the height here is about 16. So that is the point which is projected from 20. Okay, actually, this one is not part of the point. So we have 3 points here. Then we can sketch the position vector, and the other position vector is that one. Okay, and when we label them, so this is the vector when t is pi, and the other one is when the vector is at pi over 2. Okay, so but then you cannot you can't see the ellipse yet. It's just a plotting of the point and also the position vector. But imagine if you have many points there, how can you provide the ellipse? When you put anything, so you will have helix shape. So based on our previous example just now, okay, this one, we have shown that the direction is anti-clockwise. And then because of the function that is x and y are the same, okay, because the direction is coming from the y-x plane, yeah, because it's a curve, whether it is clockwise or anti-clockwise direction, is coming from the x and y, so we can use this result. So this result have shown that the direction is anti-clockwise. So since there is anti-clockwise, so imagine that we have this direction, then what you can draw there, it looks like you have very many circles, right? Maybe I should cannot do like that, or maybe I can just a second, yeah, just confusing. Okay, so to provide the ellipse, so we don't have this. So since it is anti-clockwise direction, so it's moving like this, like that, and like that. Okay, it looks like this. Maybe I should change the color into yellow, maybe. Okay, so it's keep increasing in anti-clockwise direction. Oh, sorry, this one and that one and that one, and then it keeps moving. Okay, So that is the direction, which is when you look at from the above, it is always anti-clockwise direction. So that's why you can get the ellipse shape. Okay, when we are talking about the sketching the helix, if your point that you have is not so much, just a few points that you have, so it might be your sketching is not so accurate. For example, that the thing that I sketched just now, because now we have only 3 points, so I'm not sure, maybe I should draw it to be okay, that is my starting point, right? This is my starting point. I know that the direction is anti-clockwise direction. Whether the height is increasing very rapidly or very slowly, just like that. If it is increasing very slowly, then I have to provide very many circles before I proceed to this point and so on. Okay, so then how can you know that your height, your slope is large or you have a smaller slope? It depends on the points that you have. If you have more points, then your sketching is more accurate. Okay, as I mentioned before, for helix is quite it's not so accurate if sketched by hand, because yeah, because you have to provide very many points in between, right? You have to provide all the point so that you know what is the slope that you have, right? Okay, so in this case, I would say that the more point that you have, so the more accurate your sketching, because when you provide more points, so you know exactly the slope that you have, rather than if I just use my previous 3 points, so I'm not sure about the slope that I have. Okay, so as long as we know that it is anti-clockwise direction, and we can see that it is anti-clockwise, and then it is increasing because from the function given that when z equal to 5t, so we can see that the helix will is increasing when the value of z is also increasing. So to determine the exact slope, then you have to provide more points so that you can have more accurate sketching. So we're done for the helix shape. So now we go to another kind of vector function, where you can see here now your vector function is in terms of xy, not the parametric equation. So remember, I told you before on the previous lecture, I told you that there are two type of sketching, which is if your vector function is containing the parameter t, and the t is should be in some interval, so your sketching is curved in space or on 2D. But if your vector function is in terms of x and y, so you cannot see any parameter, right? So just x and y. So meaning that your sketching, your graph sketching is a surface. So how can you obtain the surface here? So remember, you have done map method 1. When we are talking about surface, meaning that your sketching should be on 3D. Okay, and here you can see that we have the IGK, so you're sketching on 3D. So how can you obtain what is the shape of the surface that we have here? So according to the function given here, what we can have is you just look at the component. You can see that the component of x is x. So x is x. We just declare x is x, and then the component y is y. Okay, and then we know that this is z component, so you can see that z equal to x squared plus y squared. So now you ask yourself, so we have x, x, y, y. Just declaration. We just declare the x and y. So now we have only this equation actually. So can you tell me what is the surface? What is the graph of this vector function actually? Where you have to relate with the sketching of multivariable function that you have learned in Math Method 1. Yeah, I teach that before. So the topic of sketching on multivariable function is on the last chapter. Whether you remember or whether you like it or not, then you have to face it again here. Okay, so can anyone remember that? What is the shape of this? Okay, for those who already forgotten, then you can check your previous notes. And actually this one is the a bowl shape or parabolic shape. Paraboloid, we call that in 3D is paraboloid shape. Or in simple form, we can see that one is actually a bowl shaped concave. So this is X and this is Y. So I'm not going to re-explain about the sketching, and you have to look at in the Math Method 1, and we already implement that in Math Method 2. Now you need them again in vector calculus. Okay, so that is your surface where the graph of the given vector function. Okay, next, how about this one? Find a vector function. Okay, now it is a bit different. You are not sketching, but you have to find vector function which can represent the curve of intersection. You have the curve. You have to find the vector function of a curve, meaning that you have a curve, whether in space or not, depends on your information provided here. The intersection between a paraboloid, you have two surfaces here. You have two surfaces. Imagine you have a paraboloid and you have a cylinder and you have to intersect them. So when you have surface and surface, so the intersection between surface and surface, you will get curve. Remember, if you have curve, intersect with a curve or line and a line, you will get a point. But when you have a surface and you match them together, you will get a curve. So now we want to find the vector function of this curve, where the curve is, we got the curve, or the curve is obtained by the intersection between these two surfaces. Okay, if you are given the information in xy, I mean in the function in terms of xy and also z, how can you convert into vector function? So actually the process is not so complicated. It is just easy. Okay, all right. So here, okay, based on the information given, so just look at here. Doesn't matter what is the name of that particular graph. Just focus on the equation that we have. So you are given the function of z, which is 4x squared plus y squared. And also you are given y is equal to x squared. So you can see that y depends on x. Z also depends on x, right? And at the same time, alright, just look at here. Look at the simplest one here. Y depends on only x. Okay, and then z depends on only x and y, but y here still depends on x. So meaning that the independent variable here that you're free to choose any parametric equation is actually just x. Okay, I think, okay, for my student, when I teach them in the Math Method 1, I will say that for you to develop a parametric equation from a given function, always start with the simplest one. So don't what I want to say, jangan susahkan diri, okay? So now what is the simplest parametric equation of x? Since x is the independent, everyone is depending on x, so x free, you are free to choose any parametric equation for x. So let's choose the simplest one. So can you tell me what is the simplest parametric equation of x? The simplest one, this t. Parametric equation is a equation where there is parameter. And I choose t because it's a common, or t is always favorite. Okay, but if you want to choose t squared, also possible. Okay, but don't jangan menyusahkan diri. So we just take the simplest one. So I'm choosing t. So when you see that, when I choose, actually the okay, just first we choose x equal to t. Okay, and then can you obtain the y, the parametric equation of y? Of course you can, because when you choose x equal to t, so your y becomes t squared. So now you have x and y. When you plug in the parametric equation for x and y into the equation of z, and you will obtain that z equal to 4. So x is t, so t squared plus, so your y is t squared, and then you square the y, so you have t4. So now you have already all the parametric equation for x, for y, and for z. Once you have all the parametric equation belongs to x, y, and z, so meaning that you can get the vector. You just rewrite them into a vector form where, mana lagi saya nak tulis ni? Okay, so where, let's say the vector function here, I put f again. I'm using f in terms of t. So then just copy all the component, which is your parametric equation for each component. So your x is t, your y is t squared, and then your z is 4t squared plus t4. So that is your vector function. Vector function of the curve of intersection between this paraboloid and this cylinder. Okay, let's say some of you want to choose t squared. So your y here will be changed to different value. I mean, not value, but a different expression, which depends on the t that you choose. And then your z also different. But when you plug in the t and you evaluate the value of x, y, and z, the sketching of them still the same. Okay, even though the parametric equation here is different, but when you plug in the specific t, you choose t and you put into the vector function here, this one supposedly different lah, sebab bergantung kepada t yang awak pilih kat sini. So dia akan dapat point yang, maksudnya graph yang sama, which is the curve of intersection. So meaning that I would say that the vector value function, when you want to convert from the Cartesian, so the function is not unique. Bukan satu saja bentuk, it can be many. So, but then don't just burden yourself. Just take the simplest one, which is t. Okay. So the answer is provided. Okay, so that is my explanation. Okay, so for the graph sketching of the vector function, here I put a summary. So if you are given any function in terms of x, y, z, we can always write down a vector form of the equation. Okay, so this one is for a function, any function in terms of x, y, z. For example, we have this equation in x, y, z. So we can always say that now you can see here y depends on x and z. So let's say we want to have the equation in terms of x, y, z. So we can say that because x and z, they are free, so you can just say x is x. So the component of x is x and component of z is z. And then component of y depends on x and z. We just substitute the y is equal to the 2x squared minus 5z squared, where it is understood that because we define the vector function here is in terms of t, so we can say that x is the function. X is not a constant, but it is a function in terms of t, where we call that as a parametric equation. And then z also is the function of t, where we have this one. Okay, we have this one z and this one x. And then how about y? So y depends on the function of 2x squared minus 5z squared, where x is a function of t and z is also the function of t, where at the end you will get y in terms of t. Okay. These are also the, okay, this one we can say this is a parametric equation. Okay, and the second way of thinking of the graph is yeah, this one if your information is in terms of xyz, but if your vector rt is in terms of the t itself, so just like what we have done before this, you have x equal to something in terms of t, y something is in terms of t, and z is in terms of t. Whether we can use the substitution method just like a quadratic, remember, or we can use the identity of trigo, where normally for that particular parametric equation we use the identity of trigonometric. For example, you have ellipse or you have a circle, so we always use the identity of trigo. Okay, so next we will look at the sum of operation of the vector function.